how easy it is to do. So also I tell somebody, you know, if I say, you know, so there's going to be a certain frequency. Let's just say, I don't care, let's just say it's 60 hertz. That's a 60 hertz signal. I tell you to increase the frequency. So that means I'm going to get twice as many signals, or twice as many cycles in 1 second than I do with a 60 hertz. Okay? So I see that this is, again, I see more waveforms here in a short amount of time than I do here. Well, what happens is that people get confused with using the oscilloscope with the function generator. I'm going to just switch back to the AC so we can see it. I'm going to increase the frequency here. And we get rid of my offset. This is the biggest, let's just do it, so let's say here I got 200 hertz, and I see this on my scope. Now if I double the frequency, I should get twice as many cycles on that screen. So I'm going to go to 400. So I'm going to change my function generator. Now you can see now I've doubled my amount of cycles on the screen. Well, I can do the same thing. So I'm going to put it back to 2 hertz, or 200 hertz. I can do the same thing with my time for division. So there, what I just did is I just put twice as many cycles on my oscilloscope using my times per division. While I'm still running at 200 hertz, I didn't increase the frequency by adjusting this. All I'm doing is displaying more of the 200 hertz. So don't get confused between adjusting your function generator and adjusting your oscilloscope. So people all of a sudden will go and adjust, well, they go, well, I got twice as many signals on my oscilloscope now. That's because they moved the times per division. They didn't adjust their frequency, they just adjusted their oscilloscope. The oscilloscope is only monitoring what it sees on the coming out of the function generator. And it's amazing how many people get confused between these two. Okay, so when, you know, same thing, if all of a sudden an easier one too is just saying, well, I increase the amplitude of it. Well, if I do it by volts per division, I can do it by volts per division. I didn't change the amplitude of my function generator. It's still at 5 volts peak to peak. It's just how am I displaying it on my oscilloscope. And we're going to go over all these. I got some worksheets that we're going to talk about. We're going to talk about our volts per division and our times per division and stuff like that. But you digital guys now, you kind of have an idea how to look that up. And I think there is an auto set here too. So yeah. So let's go back. I'm going to go back and I'm going to switch it. So let's go back. I'm going to put in my DC signal. So if you don't know how to use your oscilloscope, you should be able to click on the auto scale. You click on your auto scale down here, it should bring your signal in at the correct place so you can see what's going on. So you don't know how to use these dials yet, that's okay. And then the only thing, if it's flashing, the only one that you're going to have to change is go from the edge type. Well, the edge is okay. What you're going to want to do is you're going to want to change your level. Just change that for now, for what you guys want to do, just change it to 1. And then that'll stop it from scrolling. And your volts per division, that'll just make it a little bit larger. Your position will, bring it down to wherever you want it. That's still kind of ugly. Let's see if media works. Yeah, media doesn't. The edge is the best way of doing that. So that's what you want to do when you get into your digital. So, but if you got your MindDAG, I can help you get it. Don't have one yet? Yeah. But give that a try when you get home, and so you're not the 2/3 Tom was talking about not having their laptop.
We're all trying to figure this stuff out. Nobody will show you how to use it.
Yeah, so yeah, it's way too complex to be thrown at you without. There's just so much. First of all, we need to know where do we get that signal. I mean, that was your first question was, where the heck do I even wire that up? How would you know?
I'm still at that part.
Yep. So it's kind of funny, you know, so the analog output is the same one that we use for our set AO voltage. It's the same one. The only difference is that we're using a different software instead of set AO voltage, where we're just giving a plus 5 volts. You know, like we're using from last DC. Now what we're doing is we're setting this AO 0 voltage, now using the function generator, and now we're just giving it a sine wave. Or a square wave in your case.
0 to 10. That's what the 0 to 5 and 0 to negative 5.
Alright, so the guys that are in digital, is that enough information to get you going, hopefully?
A little bit.
Alright. The oscilloscope, being able to use the oscilloscope so you can see the signal, that's the big one right there.
So I was, but it was also.
Alright.
I was also pulling instead of just going to 0.
So that's the non-soil waveforms, and we'll talk a little bit, we'll come back to that chapter, but I just wanted to get those guys up to speed here. Alright, so if we take a look at our, so we kind of went over all our different types of measurements that we can have, the cogs of all your units. Let's find my... I'm a stickler for the 5 things about a waveform. You'll see that on the quizzes. Graphing properly. We're going to talk more about graphing as we get through the theory of this stuff, and we'll be getting a little bit more. Let's see here. Lost my worksheets. That's all right. All right. So if you dig out your worksheets. Take a look at some of those so we can get you started on some of those worksheets. And these are Alright, so I just made up some real simple ones. They're not, just so we can just kind of get the hang of it. If you're going to start working ahead, I'm not going to spend. We're going to talk about radians. This is on section 83. This is our next section that we're going to talk about. But if you're working ahead, I just want to make sure that don't worry about this one. Don't get too worried about doing this one. Don't worry about the conversions. Because what I find out is that I spend a whole day teaching fractions. And I'm not about to teach you fractions because I want to teach you AC. So when you're doing conversions for radians to degrees and degrees to radians and stuff, you have to know how to use fractions. And I'll tell you, most people can't remember how to do fractions. And myself in particular. I'm a lousy math instructor, I'll tell you that right now, unless it directly applies to electronics. So I'm going to leave those guys, but you'll go over that, you'll learn about converting degrees and radians in your math classes, and I'm going to leave that to the experts. But some of the ones that I do want you to know is how to calculate out the period, how to calculate out frequencies, how to do your conversions. So to calculate out, so on the first worksheet here, it says, calculate out the period for the following frequencies. So how do I calculate out 1 kilohertz? What's the formula to calculate out this period?
1 over.
Yeah. 1 over what?
1 over 1 kilohertz. Or it's 1 over frequency.
Yeah, 1 over. So all I'm going to do is it's just equal to the inverse. So you should be able to use your thing on your calculator. Mine is the 1 over x key. That's the same as dividing it by 1. If you have the other calculator, it's I think it's x minus or minus x or something like that. It looks something like that. But make sure you know how to use that inverse. If you don't know how to use this reciprocal key, let me know. Let's get you up to speed because it's very important. If you don't know how to use your engineering notation, let me know and we'll get you up to speed. It's going to be very critical that you know how to use your engineering notation, your exponent key.